Greetings. Welcome to the first time that I have presented a tutorial here at NANOG. It's very interesting because I actually sat in on the first-timers briefing earlier in this room just prior to this presentation, and I felt guilty because I am not a first-timer at NANOG, but it is the first time I have been to one of the meetings in about 10 years. So it has been a very long time since I have been here. I recognize faces of people that I probably should know their names. So if I look at you funny, it may be because I'm trying to remember what your name is. So please do, for those of us that have very bad memories, make sure that your name tag is, I'd hate to have to reach up and turn your name tag around. So welcome. A little bit about me. My name is Alan Clegg. I work at Internet Systems Consortium. We do DNS and bind as the current maintainers of the bind software, and we also provide ISC DHCP. You can reach me that email address. If you want to call me, feel free. And if you want to do the Twitter thing, I don't really get it, but every once in a while I post something. So actually it seems to me that Twitter would be one of those things that network operations people would actually use, because the ability to transmit data to a massive number of people as opposed to like an email system. Of course, I guess I have to get the stability thing down before it's really something that we would think about using. A little bit about my employer, ISC. We are a 501c3 based out of Redwood City, California. We have about 40 employees, and that may be something that interests you, because if you think about the fact that ISC has 40 employees and approximately 80 to 85% of the installed base of name servers on the internet run our code, you might think that we would be a huge company, but we also run things like the froot. So one of the 13 root servers is also maintained by those 40 people. So it's, many of you probably have operations staffs that are larger than our entire company, and it's pretty impressive that we're able to do what we do. We are a nonprofit public benefit corporation dedicated to supporting the infrastructure of the universal connected internet, blah, 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 blah. We do stuff for the internet because it's the right thing to do. We are a nonprofit, so we do not have shareholders. We make money off of our support contracts and people becoming forum members. So if you're interested in supporting the continued operation of ISC, feel free to go to our website and find out all sorts of stuff. I was at OSCON, the open source convention, a couple of months ago, and I wrote a note up on their board that said, deploy DNSSEC now or something bad might happen. I was doing a BOF, so I was trying to get people, kind of curled up and interested in DNSSEC. And what I got was somebody that wrote a comment that said, define a security standard for DNS that we can deploy and the operator will. And I thought that was interesting, because I thought that DNSSEC was a pretty well-defined standard. It's been in process now for, what, 10 years? You would think that the standard was in place. But what I've discovered, I'm the instructor of the ISC classes, what I've discovered is that engineers think one way, and the people having to do deployment of said software think another way. And sometimes our engineers just don't make things as easy for the guy that has to deploy things as they should. And I think that may be, I asked at the BOF, I said, so who wrote the note up on the board? And apparently whoever it was wasn't there. I was really disappointed, because Google was doing a presentation about writing applications for Android at the same BOF session, the same time as I was. And it turned out that they gave Android phones to everybody that attended their BOF. So I kind of got screwed on that one. I said, you can have all of the free software from us that you want. And then I realized that everybody already gets that. So I could not find who actually wrote this comment, but it does go back to something that we really do have to understand. If it's not easy to deploy, if it's not something that actually just works out of the box, why do we want to deploy it? Well, since this is the North American Network Operators Group meeting, how many of you have a mandate either from your direct customers or from someone else to deploy DNSSEC? Okay, so some of you have .gov customers. Do any of you just feel like it's a really cool thing to do, so you're going to do it? Well, that's good. I like that. That's a really good, because usually when I say that, people are like, ooh, this is ick. Why would I want to deploy something that could possibly break my entire infrastructure? Why would I want to put something out there that if someone else messes up, it appears that my network has failed, my DNS is gone, so why would I want to deploy this? Well, it's the cool kids that deploy stuff early. And being the cool kid is kind of a neat thing. I think that we have deployed, we do now have good software. 9.7, you'll see, you can't see it. Every year at our company meeting, we have a new t-shirt, and it has something to do with whatever occurred the previous year. 2008 was the Kaminsky bug, so that was all your UDP port or belong to us. Last year, it was the deployment of the release of 9.7. If I turn this the wrong way, I'll choke myself. Prior to 9.7, it was hard to do DNSSEC with bind. I know because I taught the classes. I do the labs. I have people sitting in the classes trying to do things, and weird stuff happens, and if you don't get all of the command line arguments right, then you're doomed. And when you're doomed with DNSSEC, it's very interesting because it's binary. It either works or it doesn't work. And when it doesn't work, people that are using validation against your zones, they're gone. Okay? I mean, your zones are vanished as far as they're concerned. Coming back with a serve fail, that's probably not what you want to do with a large customer. So, I would really love to go directly to the deploying DNSSEC with 9.7. The problem with doing that is that whole section only takes like 2 minutes. And I'm supposed to be up here for an hour and a half. Everybody's looking at their watches going, oh my God, what have I got myself into? That's how good 9.7 has really made life. Okay? When you see the last set of slides up here, you will really appreciate what has gone into the process of getting 9.7, getting DNSSEC set for humans, as opposed to for ISC engineers. One thing that I noticed across a couple of mailing lists, even within the last week, is now that we have a signed root and everybody's starting to talk about DNSSEC, there's a lot of people that don't actually understand how it works. Yeah, there's some signatures and stuff, but the actual chain of making sure that this stuff validates, people don't quite get it. So what I'm going to do for the first couple of minutes here is actually go across and explain DNSSEC. Does anybody deploying DNSSEC already? You already got it up and running? You were mandated. I see that.
We had it up before the mandate.
Awesome. Very good. Well, considering that I think, 60% of .gov is still not signed, and there have been some very interesting outages because of different things, like the state of Virginia just went away for a week. U.S. Geological Survey have been having real interesting problems getting DNSSEC deployed correctly. And I honestly think that if people really understand how it works, then you're going to understand how not to break it and the things to be very careful of when you do. I've gone to a lot of vendor talks where they'll go in and you're like, oh yeah, you just click this button and DNSSEC magically appears. That's really good until it just magically disappears. So make sure that if you're looking at one of the solutions that's a black box type project, make sure that you ask them what the fallback is. If something goes wrong, what procedures do I need in place to get it working? So let's talk a little bit about what is DNSSEC. Well, first of all, contemplate for just a moment the amount of trust that we put into the DNS infrastructure. Okay? Personally, my phone rings or wakes me up in the morning. I pick it up and I check my email before I have even rolled out of bed and put my feet down. Okay? I am checking the news, checking my email. I am already relying on infrastructure before I even get out of bed. Now, I will admit that I am probably the only one in the room that does that, right? Or not. We talk about securing all sorts of things. We talk about securing air flight. We talk about securing bridges. We talk about securing BGP. We talk about all these things. But for the longest time, DNS was one of those things that it just works. It's all good. Nobody's really attacking DNS. It's all, it's good enough. Well, unfortunately, that isn't really the case. If DNS were to suddenly become unreliable or untrustworthy, what would the result be? At OSCON, I gave this same slide, a very different presentation, but the same slide here, and I said, okay, the first thing, the reference guide of the internet, who knows the IP address of Google? Could you get to a Google front end if you didn't use DNS? And of course, one guy in the back goes, I could, because he works at Google, apparently on their DNS infrastructure, so he kind of knows these things. But all other mere mortals would be in the dark. That seems to me to be something that we rely on very, very heavily, but a lot of times it's just that little, it's a core component, but it just works, so we don't really worry about it. This concerns me. Uh-oh. Okay. How much did I miss here? Oh, no, okay. So we all have recursive caching servers. There's millions of them out there on the internet. Every one of them needs to be able to look up data from millions of zones. How do we secure this? Well, the things that we had in place prior to DNSSEC being put forward as a standard, we had TSIG. TSIG was fine, but it used shared keys. So can you imagine, now you all do use TSIG to do your transfers between masters and slaves, right? So you know the pain of having to deploy these new keys, because I know that you change these keys at least every 3 months or so, right? Yeah? No? Yes? No? Okay. Think about it. Think about what procedure do you have in place to roll the keys for TSIG? Do you use the same keys across all of your slave servers from the master when you're doing zone transfers? Okay. So we have one key that we use for everything, and we haven't changed it in the last 5 years. How is that going to scale when we need to give a key to everyone that uses our name servers as recursive servers? Well, obviously it's not going to. There's no way to distribute a secret key that is going to scale well. So the central concept of DNSSEC is that we rely on the existing data, that nothing changes. So older versions of software, older resolvers, older, whatever, can still use the data. But we now add a digital signature across a resource record set. So the validating resolvers can use this signature to prove that the data has not been molested as it crossed the network. Okay, sounds good. Sounds simple, right? We just do signatures and it all just works. And unfortunately, that's where a lot of people's understanding of DNSSEC ends. They know that there's a signature involved, and they know that there's some keys involved, but they don't really understand the chain as to how it all actually works to validate. DNSSEC is based on public key asymmetric cryptography, which means that there is a public portion of the key and a private portion of the key that is used to sign the data. You, as the owner of the data, as the person who is the authoritative source for the data, uses the tightly held private key to sign the data. You then make the public key available to anyone who actually wants to validate your information. You actually put it into your DNS, into the data. Awesome. Now I retrieve your key, the public portion of the key. I can confirm that the signature on your data is valid. But wait a second. I don't trust DNS. That's the whole point of this. So I just inserted a public key into an untrusted mechanism, and I'm using that to prove that the data is good. Anybody see a problem with this? Doesn't look like it actually works. Well, we'll get there in just a second. The public key is published via DNS so that the validators can retrieve it. Public key is then used to validate the signatures and thereby the DNS data. You get the AD bit, authenticated data. It's guaranteed to not have been changed from the person that was the authoritative source. There's a lot of very interesting assumptions in this chain at this moment. And there's one that actually falls out at the very end. We'll get to that. DNSSEC provides cryptographic proof that the data received in response to a query is unmodified. So you publish that your A record was 10.0.0.1. The person who receives it checks the signature. Yes, the A record is 10.0.0.1. Nothing bad occurred in transit. I can use that data. It does not deal with validating dynamic updates nor with master-to-slave data transfers. Your master server, the single source of your authentic or of your authoritative data, is where you sign the zone. You then push that data out using whatever mechanism, zone transfers, to the secondaries. That is not dealt with using DNSSEC, that transfer. Only the actual authoritative source to end user. So if you want to validate these things, you actually need to use TSIG. So DNSSEC-enabled authoritative servers provide digital signatures across RR sets in addition to the standard DNS response. So, an RR set, familiar with the term? If you have a single machine that has a single IP address, then you have an RR set that contains one record. If you have a machine that has a domain that has 5 MX records, all 5 of those records are packaged into one single response. That is an RR set, and that has a signature on it. So if you have a single machine with 3 interfaces or 3 different IP addresses, you do a single query, the response comes back with all 3 of those answers. There is only going to be one signature across all 3 of the answers because it is a single RR set. The DNSSEC validating resolvers provide authenticated responses with proven integrity. Your resolver, your recursive server, now does the job of looking at the response that it got, seeing if there is a signature, first of all. If there is there a matching public portion of the key? If there is, are we able to prove that that public portion of the key is good? If we do, then we confirm that the data is unchanged. We respond to the end user with that information. So clients using the validating resolvers get guaranteed good results for some definition of guaranteed. Any of you do cryptography just for fun? Because those are the people that always come up to me after I had this that said get guaranteed good results, and they said, well, it's only guaranteed for as good as the algorithm is. Like, okay. Well, if you're using certain algorithms, there's a chance that somebody could reverse engineer or could crack the key. Okay. For me, it's good enough. I don't do the hard math. As long as the people that have come up with the standards, who've been through the review process, say that it's good enough, for me, it's good enough. Data that does not validate provides a serve-fail response from the upstream resolver. So if someone has modified a bit of data in the RR set that we assigned on the other end, I try to do the validation. Validation fails. My resolver, my recursive server, sends back a serve-fail response to the client. Well, why didn't we send back DNSSEC validation failed response? Anybody deal with any companies or government organizations that don't have very large budgets or have software that was written for Windows 98 and doesn't run on anything newer? Well, if you sent back a response of DNSSEC validation failed, those systems aren't going to be able to figure out what you meant. So we had to go to least common denominator and send back something that everyone knows, because serve fail was from the beginning of time. This is how we know that everyone who gets a response of DNSSEC stuff didn't validate gets or doesn't attempt to continue to get the data. So we're now able to prove that the data hasn't changed between the authoritative server and the validator, because we've looked at that public portion of the key. We've validated the signature with that public portion of the key. But we still don't know that we can actually trust the public portion of the key, because it is in the same resource record, it's in the same response that somebody may be goofing around with. And if we just trust it, then why doesn't the bad guy just insert his own public portion of the key, which he has pre-generated the signatures, and he sends it all back, and hey, yes, it all validates, it's all good, let's just continue on. That's not good enough. Now that the root is signed, it's very easy to create trust in a signed zone, assuming that the chain of trust isn't broken. I started with ISC about 4 years ago. And when I did, I was brought on as a support and training, into a support and training role. And I was really excited because the training, I was going to get to go out and teach people about DNSSEC. And we were going to do all this really cool stuff. That was going to be one of the big topics. And then I went to the first class that I was teaching, and I noticed that the DNSSEC portion, is we had someone else that I came in and actually replaced them as an outside contractor. And the DNSSEC portion of the class was only about 3 slides. It's like, DNSSEC is hard, you can do it, but it's not fun, go away. And that was the whole reason that I had wanted. I was really excited because I was going to be learning something new and deploying this DNSSEC stuff. And we looked back at the information that as to what people actually wanted in the classes, and they weren't interested in DNSSEC because it costs the person who is implementing it money, time, resources, bandwidth. But until you get somebody at the end that's actually doing validation, there's no use to it. And there was no traction whatsoever. Why was anybody going to ever want DNSSEC? And then 2008 came along. 2008 changed the world. Changed the way I'm teaching classes. I now teach a 3-day DNSSEC only class. That never would have happened prior to Kaminsky's finding. So, now that we have a signed root, 5 years ago, people would have laughed if you ever said that the root was actually going to be signed. There were other things put in place because, again, there was no gain in actually doing it. DNS infrastructure was good enough. There wasn't a need for this additional layer of security, and it only cost you money. Why would you ever want to do this? Well, the root is now signed. DNSSEC is based on a chain of trust. At the top of every chain of trust is a trust anchor. The trust anchor is one of two things. It is either a hash of the public portion of the key that is used to sign the zone, or it is the public portion of the key itself. One signed root means one trust anchor. How many of you have deployed a validating server? You done that yet? Okay. Not hard, right? Not excessively hard. I mean, you insert one entry in your named.conf, assuming you're running bind, and turn on validation, and hey, it just works. Magic. And then half of .gov goes away, and you wonder why, and we'll get to that. Until all the TLDs are signed, it's not quite as easy as just inserting a single trust anchor. And the reason is that we have these chains of trust. So I trust the root. So as long as .org is signed, I can build a a link down to .org, and I see that isc.org is signed, so I can follow down, and it all works. Signatures are intact. But .com isn't going to be signed until later, mid-2011, late 2011. Same with .net. So I kind of have a problem. Trust anchors, until we have all of these chains in place, you have to go out and gather these trust anchors and add them to your DNS configuration. Now, when the root was signed, that made things a lot easier, because that inserted 15 or 20 zones right off the bat that I don't have to manually maintain. But for right now, if I want to validate something in .com, I have to insert an individual trust anchor for that specific zone. So what do these things look like? In bind, trust anchors are added in using a trusted keys statement. So in your config file, you're going to have something that says trusted-keys, open brace, dot, which is the root, that is the label at which this key is good, the algorithm numbers and some other flag fields, and then the actual data that you have retrieved from the root as the public portion of their key. How do you go about retrieving this public portion of the key? Well, it's easy. I can do a dig.dns key. Pick out the one that's 257 and insert it. But if I don't trust DNS, then I can't do that. You go to IANA's website, you find the .gov, or not .gov, that'd be if you want to need the .gov key, you don't need that anymore. You have to find some other mechanism to retrieve this key. You cannot just use DNS if you have any thought whatsoever that someone bad is trying to do something bad over this channel. So now you have a trust anchor based at the DNS root or the dot up there, and anything below that can actually be validated as long as the thing below is signed and a little bit of magic occurs. So once a trust anchor is inserted, how does it actually create the trust that follows down the tree? Trust anchors consist of the bits capable of validating the keys in that given zone. So if I have the trust anchor for dot inserted, then I am able to validate all of the signatures at the root level, at dot. Cool. Okay. But how does that help do the tree thing? Well, you got to realize that there are two keys inserted into every zone. There is a zone signing key, or ZSK, that is used to sign the resource records in the zone that is being secured. There is also a key signing key, or KSK, that is used to sign the zone signing key, so it only signs the resource record set of the DNS key, and a hash of the key signing key is given to the parent to be included in the parent zone. So this is a DS record, or delegation signing record. Delegation of signed zones includes a new resource record type, as I just alluded, the delegation signer, or DS record. It is the hash of the public portion of the child's key signing key. So if you trust root, if I trust dot, and I happen to find a DS record for org in dot, that DS record is going to be signed using root's key signing key. Well, I have a trust anchor in place, which means that I trust that portion of that I know that that public key is the one that was good at root. I can then prove that the zone signing key is good at root, which means that I can prove that the DS record is good because it's going to be signed with that zone signing key, which was signed with the key signing key. So now I have the DS record, which is the hash of the key signing key in the child. Now I go into the child zone, I pull out his DNS key resource record, and I can hash it, look at the DS record, compare the results, and bingo, I now know that I have a good key signing key for the child zone. I then use that key signing key to validate the zone signing key. Then I'm able to validate anything within that child zone. So, sounds good, right? Shouldn't be completely scared yet. If the DS record in the parent is signed using the parent zone signing key, we know that the DS record is valid. If the hash of the child's key signing key record matches the DS record, then we know that the key signing key is good. We then use the key signing key to validate the zone signing key. So we know that the zone signing key is good. And then we know that the zone signing key is good. We can validate all other resource records in the zone. Easy enough. Everybody ready to deploy? No? Very easy to conceptualize, I think. Let's look at a living example. So here is www.isc.org. Now, if you have not used DNSviz.net, you really should. If you're deploying DNSSEC, this is one of the coolest little gizmos that you can find out there. I'm sure that these slides are going to be available online if they aren't already. It is a Sandia National Labs project. It allows you to do some really cool things looking at these chains of trust. So first thing that we look at is that we have the root. And in the root, we have a DNS key 008-19036 and a DNS key 008-41248. And that is a key signing key and a zone signing key. Now, the zone signing key is signed with the key signing key. So if we have a trust anchor of the 19036 key, then we know that we are going to be able to use the data in the zone. So we have the DNS key. We also have two DS records, and these are actually for .org. So there are an algorithm 1 and an algorithm 2 DS records, and they are signed using the zone signing key. So we know that those DS records have been unmodified. They are unmolested at this point. In .org, we find a DNS key, which is algorithm 7, and the key ID is 21366, and it is signed, or it has, and that is a key signing key. So the purple filled in is a key signing key. We have the DNS key 05919, which is the zone signing key. Since we had the DS records in the parent, we know that the key signing key is good. Since we know that the key signing key is good, we can validate that the zone signing key is good. Since the zone signing key is good, we can prove that the DS records that we find for isc.org are good because they're signed with the zone signing key. So now within isc.org, we find that we have two key signing keys, one of which matches the DS records in the parent. That key was used to sign 18516, which is the zone signing key for this zone. And then within this zone, we have SOA records, Quad A records, and A records that are signed using the zone signing key. So we know that all of this is good. We know that those records are signed. We now see that chain of trust. As long as you have trust in the DNS key of the root is over there on the left, 19036, then you can follow the tree down and actually prove validity of the DNS resource records within isc.org. Simple, right? Ready to deploy? Not quite yet. If the DS records are not in place, then you cannot do validation. If you have something within isc.org that is signed, but you don't have the chain in place, then you're not able to prove that the key that you're using to do validation is actually one that should be used. So, everybody happy with how DNSSEC works? You see how the chain of trust is in place? All good? So far, so good? Now the 3 slides, actually it's a few more than 3, that actually show you how to deploy it using Bind 9.7. Let me begin with something here. How many of you are running something prior to Bind 9.4? Anybody running an old, nobody running Bind 8? I saw the hand was up and it went down real quick and I said 8. Okay, Bind 8, I was telling you about the company T-shirts. The one the year before was bind 8 is dead. Don't use bind 8. Just don't. It's bad mojo. Anybody running 9.5 or older? Okay. 9.6. Is anybody actually using 9.7 in production? Cool. By the end of these slides, you'll see why you really want to move to that, because some of the features in 9.7, when it was humanized as opposed to engineered, you'll see why it's a good thing. So, on the part of the recursive server, well, the recursive server, remember, is the one who's actually going to be doing the validation. He's the one that actually has to go out and follow these chains of trust and do all of the hard work of the heavy-duty mathematics. Well, in bind, the trust anchors are added using the trusted keys statement, which works out really well until that key changes. That key is going to change over time because new algorithms are brought forward, weaknesses in the keys might be discovered, or it might just be time to do it, so in 5 years they roll the key. Well, if you haven't changed this entry the day after they change the key, everything in the world is going to serve fail for you. That's going to be a very bad day to be on your help desk. You don't want to be working there that day. Of course, if you're going to retire within 5 years, you don't really care. This is a bad thing to do if you are thinking that these keys are going to change. Hard coding anything in a configuration is a bad thing to do, especially something that's going to change that you are not in charge of. When the root rolls over, they're not going to ask you if it's okay. It's going to happen. 9.7 is RFC 5011 ready, which means there is a protocol that says if a new key signing key appears in a zone for a given length of time, I am going to pull that key into my trust anchor repository. So now you don't have to worry in 5 years when the root key changes, because now you're using, instead of trusted keys, you're using managed key. Managed key says initial key is 257.3.8 and then a blob of ASCII garbage. And that says that this is the one I need to use immediately. But I'm going to keep watching to see if a new key signing key appears. And if it does, since I'm able to validate it because it is signed with the existing key signing key, I know I can trust it. And I'm going to grab that key and pull it into a database on my recursive server. So when the root key rolls over, you'll still have the initial key entry of the one that we use now, but bind will have in a database what the actual key is, and it's been able to follow this chain, so it knows that it's a good one. It's going to create a file called manage-keys.bind and a .jnl file. So if you're familiar with dynamic zones, it's very similar to a dynamic zone database. This file is going to contain the currently active key, even if the configured key in your named.conf isn't the right one anymore. So now when you restart your name server, it's going to be able to read from the managed keys file. It's going to automatically start using the correct trust anchor. There's a problem there because you don't necessarily know what key it's actually using. Because if the key is rolled over, managed keys is going to have one thing in it, the statement in your named.conf, but the actual key that it's using is something else. So there is now a newly added command, RNDC-SEC Roots. And what this is going to do is it is going to provide you with the actual information about what key is actually now in use. So instead of seeing, right now 19036 is the root key, when it rolls over, the one that is in your trusted keys statement or managed keys is going to be 19036, but the one returned by RNDC-SEC Roots is going to be whatever the new one is. So now you're able to still see which keys are actually being used, go out and validate them, possibly import them into your named.conf if you want to, keep the documentation up to date as well. Now, there is a problem with managed keys. If a key rolls over without your system recognizing that the new key was inserted into the zone, then it's not going to be able to pull it in. RFC 5011 has some specifications as to how long a key must be in the zone before we are actually able to import it. If that time period is too short, the key may be put into the zone and they may roll the zone and it's not going to actually pull the information in. So you are going to have to continually watch for little oopses like this, but you're only going to have to do, well, of course, no, they're not going to screw up re-signing the root, right? A key rollover at the root is just going to go perfectly. Yeah, everybody has great faith in that, I see. Okay. You may, at some point, need to fix the key, and you do it the same way that you did when you inserted it in the first place. You find what the actual active key is, put it in there, but under 99% of the expected circumstances, the automatic rollover is going to work for you. If your validating server is offline for an extended period of time, or you're installing old software that may have actually had an older trusted keys or managed keys entry, things to be aware of. I actually had a customer that they build a standard deployment of named.conf, and they said, well, as the key rolls over, we're going to have to keep track of the actual root key, because if we deploy this new, a new build onto a server after the key is rolled over, then it's not, the one in the managed keys is not going to match the one that's actually in use, and therefore validation will fail. So you do still have to track the keys that you have inserted as individual trust anchors, but this just makes it a whole lot easier. Okay, that's all you really have to do on your recursive server, because the validation is already turned on. All of that stuff's automatic. As soon as you insert the key, you're doing validation. Congratulations. You've already been sending the DO bit since bind 9.5p something or another. So don't be surprised, or don't think that the size of the packets you're going to be getting back are going to be considerably larger. They probably won't be. Your authoritative server, however, this is where we have some really major changes, and this is where DNSSEC for Humans really kicked in. I don't know if any of you have seen it, but I have a paper that I wrote that was called DNSSEC in 6 minutes. Anybody looked at that? You seen that? Well, it's about a 75-slide deck, and I caught a lot of heck for having written a title of something that says DNSSEC in 6 minutes. How are you supposed to read 75 slides in 6 minutes? The idea was that you could deploy a DNSSEC signed zone in 6 minutes, not that you could go through the slide deck. One of our engineers, Evan Hunt, used that as a reference. He actually had it on his desk, and when he was doing testing of bind, he would go through and he'd find the page and he'd do this and this, step 1, step 2, step 3, step 4. And he said, if I'm just following this as a list of things to do, why don't we automate this? Wouldn't it make a lot more sense to make the computer do the stuff that you just do over and over and over again? So that's why bind 9.7 came about. He looked at it and said, it's really the same stuff for every zone. We can automate this. This isn't rocket science. Well, there's a couple of things. First of all, changes in DNSSEC keygen. It generates the keys. Once you've created those keys, you insert them into the zone, either manually or dynamically. Now, here's a question. How many of you run dynamic zones? I used to think that dynamic zones were something that was just absolutely stupid. Who in the world is not going to want to use VI on the zone file? Okay? Why would there be any other interface than some kind of a text editor, stream editor, whatever, to modify a zone file? And then I had a revelation. DNSSEC makes you really, really want to start considering dynamic zones. Some of the things that we've done in 9.7 make dynamic zones not only safe, but very, very easy to deploy. I'll show you an example at the end of the slides as to a script that actually deploys a zone, signs it, and does it all because it is dynamic. No user intervention required other than typing the name of the zone. You then, after you've inserted the keys into the zone, the public portion of the key, remember, only the public portion, you then sign the zone data using either DNSSEC signed zone, or if your zone is dynamic and bind actually has access to the private portions of the keys, it does it for you. You don't touch anything. You insert, you create the zone, you create the keys, you make it available, boom, it's done. Cool stuff. Then, of course, you perform your scheduled zone maintenance. Up until DNSSEC, there was no zone maintenance that had to be done because you put the data in and it sat there for the next 20 years. It was all good, right? DNSSEC signatures have an expiration date. If you sign your data and then allow that expiration date to pass before you re-sign the zone, it serve fails. It doesn't validate. You go dark. That's a bad thing. So every 30 days, you have to do some zone maintenance. You rerun DNSSEC sign zone. Or, gee, if your zone is dynamic, bind deals with it all for you. So you don't have to touch it. Life's good. So, DNSSEC sign zone is used to create the required keys, the KSK and the ZSK. Prior to 9.7, you had to give about 25 different options on DNSSEC keygen. What kind of a key did you want to do? Well, you still have to tell it that. What algorithm did you want to use? I don't know. How many bits in the key? Well, we have a standard, so I guess I can write this into a script and have it all just do it. But wouldn't it be nice if the command line defaults actually made sense and that there actually were defaults, like for the algorithm number? If you deploy it, you're probably going to use this one algorithm number. Why do I have to specify it on every command line? Well, we now have some defaults. The default algorithm is RSA SHA-1. RSA SHA-1 was chosen because it is the only algorithm that is guaranteed to be in every validating resolver. It is the only one that was in the DNSSEC initial documentation as to a must implement this algorithm. It's not the best algorithm. It's not the strongest algorithm. It's not the most current algorithm. And it's not even the algorithm that the root is signed with. But it is the default because it is the one that will work everywhere. We also provide default key sizes if the default algorithm is used. So your key signing key, and these are based on the NIST standard, we do a key signing key of 2K and a zone signing key of 1K. Perfect. You don't have to specify that on the command line. DNSSEC keygen run with just the name of a zone, isc.org, is going to create the zone signing key using RSA SHA-1, 1024 bits for that zone. If I want to create the key signing key, I add one additional option, -FKSK. Boom. Okay? So now you know how to generate your key signing key and your zone signing key. It's going to produce 2 files per key. There's the .key, which is the the public portion of the key, and the .private, which is the private portion of the key. The .key file you can include into your zone data. In fact, you have to make it available. So both for the key signing key and the zone signing key. So you're going to insert these extra lines into your zone, run the signing utility. You put these, as I just said, you do this. You keep the .private portion secure. Well, running on a Unix box, multi-user mode, you didn't previously really have to worry too much about the data that was associated with your zone files. I mean, as long as it's read-only, that's good enough. Well, now, if someone actually even has read access to the .private portions, they're going to be able to spoof your signatures. Because as soon as I know that, I'm able to generate the RR-SIGs, the signatures that go along with whatever piece of data. Well, keeping a lot of things combined in one directory is a recipe for disaster. You have .keys, you have .privates, you have the zone file, you have the signed zone file, you have all this stuff, and now it has to have different permissions based on who's supposed to be able to read it and who isn't, and that's just a real pain. So one of the things that was actually added, and apparently I'm one slide ahead or 2 slides ahead of myself, is an option on DNSSEC KeyGen and actually on the other applications as well that says use this directory to store all the keys. So I can now dump all of my .key files and .private in one directory, secure that directory, give bind access to that directory, and not have to be so concerned about the public data that I have in the directory where my actual zone files live. So, DNSSEC sign zone signs the zone data. It creates the signatures on each authoritative record, and it transforms the zone into a machine-generated file with a .signed extension. So if I take isc.org, and the zone data is in a file called isc.org, I run DNSSEC sign zone, it's going to create isc.org.signed. Now, how many of you use your zone files to actually store things like comments? Do you keep records sorted by organization? Oh yeah, all these are in that lab over there, and all these are over there, so we keep them in different places in the zone file. Well, you just lost that. When you sign a zone, it comes out in the same order and format as if it is on a secondary. So all of your comments, all of your sorting is gone. It is now in alphabetical order by host name with the zone apex at the top. So your SOA records still going to be at the top. MX records, anything that is at the same level as the zone will be at the top of the file. But everything else in the zone is going to be alphabetically sorted. Okay, good enough. Well, the new features with 9.7 on DNSSEC sign zone was something called smart signing. I told you that you had to take the .key files and include them into your zone data. So before you signed your zone, you had to go in, increment your serial number. Don't ever forget to increment your serial number, because otherwise it doesn't transfer out correctly. Figure out which key it is that you're supposed to be including into the zone, pull that key in, and then run the signing app. Okay? I now have 3 extra steps on my checklist of modifying any given zone. Smart signing looks in a key repository or directory for the keys, both the public and private portions. If the key is needed, and if there's some metadata now in the key files that says if this key is actually active and used for signing the zone or needs to be included, I'm going to do it automatically. So you don't have to do that extra step of manually including the information. If the key files contain the timing metadata, that timing is used. This key is being used now. It's inserted. Signing is done with it. This key is not being used anymore. It's maybe still left in the zone, or it's dropped out completely. Re-signing is done with the appropriate keys. Very, very cool stuff. Now, named has a new dynamic zone configuration. So now you can say update policy local. If you've done dynamic zones, you knew that you had to create a TSIG key and you had to do all this association and you had to make modifications, and it was just a real pain. Well, now with 9.7, if in your zone section in your named.conf you have an entry that says update policy local, a new TSIG key is automatically generated every time named is restarted that is allowed to modify that zone. It is only able to be done locally. So this allows bind to do dynamic zones without any real complex configuration. A couple of other things that have been added. Auto DNSSEC off, which is the default. Auto DNSSEC allow enables the auto inclusion of keys from a zone repository or from the key repository. So if I generate a key for isc.org, bind is going to automatically look in this directory, pull in the key, and use it to sign the zone if it needs to. It's pretty neat. And then, it enables RNDC sign. So you create these keys, RNDC space sign space isc.org, hit return. Bind goes off into the background, does its thing. Congratulations, you're now serving a signed zone. No user interaction required. And then the last one, Auto DNSSEC maintain, says look in those keys for timing metadata. Is this key ready to be used? Yes, it needs to be brought in, but not used for signing yet. Oh, it needs to be brought in and signed with this given key. We now have control without doing it manually as long as we have the metadata set correctly. So, dynamic zones. You have to use this crazy NSUpdate thing. Well, NSUpdate has a new option, -L, which says use the current local key, which was automatically created by bind, so we don't actually know what it is. Set the server address to localhost, so when we do this update, it's going to occur on the local machine. It's not going to attempt to actually modify the zone somewhere else. Whoops. And then, of course, there is RNDC sign, which takes a dynamic zone, looks in the key repository for any associated keys. If the timing metadata says we should use it, it pulls it in and uses it. So, I now have something as simple as zone test.com. I'm the master server for it. My key directory is the keys directory. Now, this is taken from the directory. The prefix to this is the directory statement that is in the global options. So if etc namedb is your key directory, or is your directory statement, this will be in, the keys will actually be stored in etc namedb/keys. Update policy is local, so this is a dynamic zone using that locally generated tsig key that I don't really have to do any manual configuration of. Auto DNSSEC maintain. So we're going to look out in the key repository, look at the timing metadata in the keys, and if it needs to do something, it will automatically. And we're going to store this into a file called dynamic directory test.com.zone as the zone file. Well, that's really cool. So far, so good. I now run DNSSEC keygen-k, and the -k is the key repository directory. Apparently, I've dropped the slide. I apologize. This says look in etc namedb keys for the .private and .key files, and I'm creating it for test.com. Since I do not specify -f ksk on the first one, it's creating the zone signing key. The second one creates the key signing key, dropping the data into that same directory. RNDC sign, test.com, boom, congratulations, I now have a signed zone. Used to be hard. It's not hard anymore. Adding or removing zone contents is now as simple as NSUpdate-L, hit return, update add, test.com, a, TTL, and all the other stuff. Hit return, send, hit return. It's automatically re-signed. You don't have to run sign zone. The serial number is automatically incremented. Life's good. Dynamic zones, I went for a job interview many, many years ago, and one of the questions that they asked me was, what do you see as the use of color monitors? And, of course, this was back in the day where I was happy with my green and black screen. And I said, I really don't see anybody using color monitors beyond, CEO and CFO type people that are doing presentations. I mean, I don't, we aren't, there's no need for that. Well, I was very wrong. I now have more colors on my phone than all the colors that were available in the world at that point, I think. And I was wrong about dynamic zones. Dynamic zones, to me, initially were just, that's crazy. Okay, yeah, maybe use it for DHCP updates, something like that. But you're not going to use it on a day-to-day basis. Using NSUpdate allows you to immediately know if what you did worked. It does error checking for you. It's very, very easy to script as opposed to doing zone edits using sed or awk or VI. You know, the people in your NOC aren't necessarily trained anymore on how to use Unix text editors. So what are they going to do? You can so easily write a web front end that takes data and just does an NSUpdate, add, NSUpdate, delete, boom, done. Automatic DNSSEC, automatically re-signing everything. No user intervention required. So the DNSSEC keygen, talking about that metadata, you now have a -P, uppercase P option, the publication date. When is this key going to be inserted into the zone? Maybe I want to create all of the keys now for from now until 2038, when we're all going to be retired anyway because the internet's going to blow up and all the machines are going to melt down because of times, right? So I can generate all of these keys in advance and create a publication date 1 year apart. So these keys will not appear in the zone until the publication date comes. The activation date. When is this key actually going to be used to sign the data in the zone? Okay, I can include the key using -P, but I don't actually want to start signing the zone with it yet. For example, key rollover, key signing key, RFC 5011, all that stuff. You want to publish the key 30 days in advance before you actually activate, start using it. Revocation date, again, an RFC 5011 thing where you want to keep the key in the zone, but say, I don't really want anybody to use this anymore. You need to be able to reference it, but I don't really want you to use it. Retirement date. When is that going to be removed as a signing key, but left in the zone? And then finally, the deletion date. When is it actually going to completely be removed? So all of these have an option of the word none, which, for a retirement date, you don't want it to ever retire, so you do none. Year, month, day, hour, minute, second. And then you can also do a now plus an offset. So I can create a zone signing key that will be published now plus 1 year. The key's there. It's just sitting there waiting for a year from now to occur. When a year from now happens, it will be published and it will be made available or made useful. So to pre-publish a key signing key, for example, without signing, you're going to run DNSSEC keygen -K in the directory that you want to store these keys into, -F KSK, which says this is a key signing key, -A none. It is not activated. It is going to sit there. It is published because the default publication date is now, but the activation date is set for none. So it's just going to sit there. Test.com, and it's going to create this K test.com, blah, blah, blah. I do an RNDC sign of test.com. It's the named is going to see that there is a publication date, but not an activation date. It's going to be smart, pull the key into the zone, make it available, but not actually sign the zone using that key. Once that key has been in the zone for a while, we actually want to sign the zone with it. We use a new application, DNSSEC set time, -K in the key directory, -A activation date now. So this is taking the metadata that is in the key and changing it, where the activation date was none previously, so we were never going to actually use it. Well, I want to make it ready. We're going to start using this key. It leaves all of the other dates intact, and then we do an RNDC sign of that zone. The zone is now signed with the existing key signing key and the new one because you now have 2 active keys. Now that the key, we want the key to remain in the zone. This is a couple of months later. We want the key to remain in the zone, but we don't want to use it for signing anymore. DNSSEC set time, -K directory, -I for retirement, now. I want the key to stay in the zone file, but I don't want it to be used to sign. I do an RNDC sign, and named does everything for you. And then finally, you want to get rid of that key completely. You want it to be deleted from the zone data. Set time -D now for deletion, and the key, and re-sign the zone, and congratulations, you've now done a key signing key rollover. Now, be aware that doing that automation does not deal with the DS records in the parent, or if you're using a DLV registry, the DLV records. So when you do this key signing key rollover, you need to generate the new DS records because you now have a changed key signing key, which you need to hash and make available to the parent. So you still need to do that manually. That's not something now. If you're using RFC 5011, it'll do it automatically for you, but I don't see .com allowing RFC 5011 key rollovers. Just isn't going to happen. So 972. It is actually it's now actually released. I think Suzanne, 972 is actually 972p something or another. Anyway. Suzanne Wolf is one of my coworkers. Yeah. Right. This introduces something that makes your life even easier. You're tired of doing all this manual creation, editing the named.conf file when you create a new zone. Well, we were sponsored by Dyn Inc. to include some code into Bind that does automatic zone creation and zone deletion, so you don't ever have to edit named.conf anymore. There is a new option called Allow New Zones. It's a Boolean, which by default is false. So if you say Allow New Zones, it's going to create a really ugly file name right now. It's the hash of the view that the zones are going to be created in. So it's machine-generated, machine-used. Probably not going to need it, but you'll see it there. You then are activating RNDC add zone and RNDC del zone. So now instead of modifying the named.conf, you pass in all of the parameters that are put into the named.conf for the given zone, and it does it completely automatic. So let's look at a sample. And these are the last two slides, so we're just about done. This is a script that I wrote that creates and signs a zone without any human intervention on editing zone files, creating keys, or anything. So first thing, we cd to etc namedb just so we're someplace known. We copy a template into master / and then the name of whatever option, the first option that we were given here. So this would be called as create zone space and then the name of the zone that you're actually going to create. So we have a template that we've pre-generated that has the $TTL, it has the SOA record, it has the NS records in it, but doesn't need anything else. Cool. We do RNDC add zone, and I'll use test.com, automatically inserts type master, file master / test.com, update policy local, auto DNSSEC maintain. As soon as that comes back, that zone is valid and live on my server. I now say DNSSEC keygen -f ksk, putting the keys into a given directory for test.com. DNSSEC ds from key says take the key and generate the DS records that I need. So this is going to create into a directory called DS. It's going to create test.com. That file is going to contain the DS records that I need to present to the parent. Then I create the zone signing key. Notice it does not have a KSK. And then I do an RNDC sign on the zone. And congratulations, you now have everything you need to deploy DNSSEC with no human interaction whatsoever. Pretty neat stuff. The last slide is basically doing the same thing. The difference here is that you're using NSEC 3. I'm not going to get into the differences between NSEC and NSEC 3, but the thing that this shows is the use of NSUpdate with the -L option to do a local update, because we need to insert a specific record into the zone before we introduce the key signing key to tell it how to do INSEC 3. There's some additional options that you need to be able to pass in. So the first thing I do there is I create a variable called salt, which is going to be 2 4-byte random numbers. We then cd to etc name.db, we copy the template file, we do the same add zone that we did before, but then we do an NSUpdate that says update add zone name, TTL of 30, INSEC 3 param, and then some information about how to generate the INSEC 3 chain. Once I've done that, then I do a DNSSEC keygen with the -3 option, which says use INSEC 3. We're creating the key signing key, again for the same zone name. We create the DS record. We create, using the -3 again, the key for zone signing key, or the zone signing key. We do the RNDC sign, and congratulations, we're up and running with an INSEC 3 signed zone. And with that, are we ready to deploy? No? Well, I tried. These 2 scripts at the very end here, literally, you give it the correct input for the zone, and you are going to need to do some NS updates to change the NS records. But you know what? That does everything you need to do to completely manage an authoritative DNS server. RNDC add zone can be aimed at a remote server that is your slave, that says RNDC add zone, and then instead of type master, it says type slave. So now you're able to centralize all of your adding and deleting of zones, not only on the master, but also on the slave. It's awesome. Well, it's better than it has been. One of the things on our roadmap for upcoming versions is automated key rollover. Right now, you still have to play around with those times and dates in the key metadata to make sure that things follow the correct standards as to, you don't delete the key from the zone before you've, made TTL, blah, 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 blah. That is one of the things that we are looking at in a future release of Bind to be completely automated. So if you have a requirement that you do key rollovers every 30 days, I see no reason that we shouldn't be able to automate that as well. So it's coming. But again, it requires the use of dynamic zones. If your zones aren't dynamic, we can't muck with them. We'll be able to do some things. We can generate the key files, but for you to include them, you've got to do it manually. Dynamic zones, it's the thing of the future. Plastic. Yes?
I actually have 2 questions.
Yeah.
One is, what's the load impact on your servers with regard to DNSSEC in terms of volume of communications as well as having to deal with the keys?
Well, the signing of the zone is the only time that your INSEC authoritative server is going to have an additional load on the CPU, because the zones are signed statically, and then the information is sent to the recursive, or to the slave servers. There is obviously additional impact when you're running a dynamic zone, but now instead of a zone that has to be re-signed completely at one time, you're going to be introducing jitter, so that instead of having all of the resource records expire, or all of the signatures expire at the same time, they're now going to be expiring little by little, and they're going to be regenerated as they're needed to be regenerated instead of all at once. So there is an increased load. I cannot tell you how much it is. Right now, there are a lot of authoritative servers out there that are serving DNSSEC data. But there are not a whole lot of people that are actually validating the data yet. So we don't really know. There's some very interesting things that will be learned. And a year from now, we'll probably have some better information. 5 years from now, we might actually know the answer to your question.
And you answered my second question.
Okay.
With regard to validation, I kind of want to get a sense of when that big switch is going to get flipped and people are going to say, hey, I'm not going to respond to you unless...
one of the things that we have discovered, and it is a painful reality, is that DNSSEC signed records are significantly larger than unsigned records. Okay, I'm looking at something like 230 bytes expands into about 1.6K. So the response used to just go. And if you go out and look at a lot of security websites, they have crazy things on them like DNS packets will never be larger than 512 bytes. And unfortunately, there are people that believe that. They also say things like DNS only uses UDP, so it's safe to block TCP port 53. Unfortunately, what happens is, as soon as you hit the 512 byte boundary, if you're not doing eDNS, well, actually, there's two interactions here. The first one is your firewall says 512 bytes, it's obviously broken DNS, I'm not going to allow it through, and it falls over, and you continually sit there and query, and you never get a response back, and you think that the guy upstream is broken, but it's your firewall. The other thing that happens is that, well, eDNS 0. We fall back to TCP. Well, if a packet is fragmented, or if it's larger than 512 bytes, or whatever has been calculated using eDNS 0, if the packet is larger than that size, we send back truncated, to which you do the same query again using TCP. Oh, gee, well, I'm blocking 512 bytes, but I didn't negotiate eDNS 0, so we were going with 512 bytes, but I responded with a truncated packet, which you then tried to get using TCP, but since you're blocking that, it doesn't work either. So we are going to, over the next year, see some absolutely amazing failures. We are going to see things that have been working for the last 20 years just suddenly fall over, and it's going to be because we haven't changed in the last 20 years. Yes? Will never happen. I personally, and this is, I don't have any reason other than my personal belief that you're never going to be able to bypass your registrar when talking to the registry. You are going to have to update the information from the person that you purchased the zone from. You're not going to go directly to VeriSign or whoever it is running .com at that point. There's money to be made here, and by bypassing one step of it, they're going to be missing out on some money. So I just don't see it happening. There's also a level of trust. I mean, do you really want to be able to modify .com directly? Oh, I'd love to. But it's one of those things that I don't see 5011 going into the TLDs. Yes? And you didn't make any faces at me the whole time. He said he was going to sit up front so that I could see the faces he was making, and I saw nothing. Oh, yeah, like you could have thrown me off. Good luck. Yes? Don't do that. Okay, the question is, okay, with dynamic zones, you cannot edit them with a text editor because they're constantly living. A lot of people at this point with dynamic zones, you can go in and say, this zone is dynamic, freeze it, now use my regular old text editor to do whatever changes I needed to do, and now I can thaw it, and it'll just continue operation, and life will be good. That's the way I used to do it. I will tell you that once you are used to the command line of NSUpdate, it is so much easier because you don't have to worry about screwing stuff up. The zone, for one thing, with DNSSEC, automatic re-signing, I don't want to have to remember to re-sign a zone, okay? NSUpdate, when I insert the record, it's done immediately. As soon as you freeze a zone, any incoming updates are dropped. Not queued, but dropped on the floor. So if this zone is actually dynamic in the normal idea of a dynamic zone, then you run the risk of actually losing valid updates. So I would strongly look into, writing a front end onto NSUpdate that makes sure that TTLs are something, are relatively sane, and then just do everything dynamically. Yes.
Two questions.
Yep.
What happens on the validating resolver when the resolver doesn't support the key signing algorithm?
It will provide the information, but it will not provide the AD bit. The issue there is that in the future there will be algorithms that we don't support with older versions of software. So there has to be a way for that resolver to still provide the data to the end user. But if he doesn't know the algorithm, he's not going to be able to do the validation. So he is going to take it, pass it on to the client, but not set the authenticated data bit.
The other question I had was, you've created your key signing key, your zone signing key. You've got them set up in your zone properly. What are the mechanics involved in now pushing that information about the key signing key upstream of the trust ID?
Insertion of the DS record into the parent is going to depend on who you use, who your parent is. .gov has their own method of doing it. There's a web page, .gov.gov, that has what you log in with your credentials, proving that you are the valid person to be able to do that update. I use Joker.com, and I sent him an email last week that said, "So when am I going to be able to insert a DS record?" Because I have a couple of .orgs that I could create, change the trust, and the response was, "We don't know if we're going to be doing that." And my response was, well, if you don't know if you're going to be doing that, I'm moving to somebody that does. So, but again, I don't know how, Dine Inc., I don't know how GoDaddy, I don't know how Joker, I don't know how VeriSign, I don't know how any of these people are going to be doing it, but it will be something that they are going to have to do.
Can you assign multiple algorithms to a record?
Yes.
So that you can
Yeah.
support the old one, but also evolve to.
Yes, and in fact, that is actually how a key rollover involving algorithm change is actually done. The problem with doing that is that when you sign a single resource record, you get, with a single key, you get one blob of RRSig data. When you sign it with a second key, you now have two blobs of signature data. Most of the time, your signature data is larger than the RR set itself. So when you start doing multiple keys with multiple algorithms, or even multiple keys with the same algorithm, you end up with a bloated zone file that probably isn't what you want to happen. Now, there are some issues that we've had to deal with legalities of certain software in certain countries. The RSA algorithms, there's some prohibition about using them in Russia to do actual signing of the zone data. So they needed to introduce a new algorithm, the ghost algorithm sets. So, for you to be able to validate, and this goes back to your question, the other question, for you to be able to validate a zone that was signed using the ghost algorithms, you're going to have a validating resolver that knows how to do ghost. But you're also going to need to know how to do RSA SHA-1, 256, 512, etc. So with those zones, you may see a single signature with the ghost algorithm, or you may see one with ghost and one with RSA. So there are times that you will see multiple signatures using multiple keys, multiple algorithms.
I could see a management tool for that coming up.
And I'm sure that if you write it, they will come. Any other questions? Not bad. Well, thank you all for coming. I appreciate it. As I said, ISC is a 501c3. I'm only here because people have bought support contracts and have become forum members. So if you feel like supporting us, please get a support contract, become a forum member, come to our training. You can listen to me do this for 5 days. Wouldn't that be exciting? Thanks again.